I would like to welcome you again, once again, to Black Sea Connect's Marine Litter Action Forum. I want to start by introducing myself. My name is Olgaç Güven. I have been working on marine litter since 2019. As a matter of fact, 2009 will be much more better to say. Now I'm so happy to be here and to be able to interact with that distinguished guests list. So the next session of our forum is on plastic circularity, which we believe the circular economy considers every stage of the production line, from social to climate to economic benefits, provides these benefits, and it's vital to stop the plastic pollution. So in this session, we aim to provide you a perspective on tackling marine plastic pollution within the scope of the circular plastic economy. I would like to welcome our online and offline speakers, Professor Nilgün Kırancılı on site from Boğaziçi University, Dr. Josh Liu from Hellenic Center of Marine Research, Mr. Feng Wang from United Nations Environmental Program. He's going to be with us with online participation, and Shardur Agrawala from Organization of Economic and Cooperative and Organization for Economic Cooperation and Development. As a starter, I would like to give the floor to Professor Nilgün Kırancılı. She's a professor as a full-time faculty member in Boğaziçi University. She is the founder of the Sustainable Development and Cleaner Production Center at Boğaziçi University. Also, she has several responsibilities at United Nations Sustainable Development Solutions Network of Turkey. Nilgün Hoca.
Thank you so much. Good afternoon, dear Black Sea Connect Consortium participants. I'm very happy to be here. Thank you very much for your kind invitation. Today I will be talking about plastics, focusing on energy and chemical recovery issues. That's why I was told for. So I will bring an integrated approach for plastic waste management, emphasizing the circular economic aspects with pyrolysis and incineration processes. Let's start with the source of this polymer production that comes from crude oil, and where we have huge amounts of possible chemical production issues from crude oil. And also, of course, we have gas production together with water production. So the chemicals produced from crude oil has a very important market on the international basis, from which we can also produce virgin polymers that we are using nowadays. When we look at the plastic production, it starts on the industrial scale after 1940s, especially in Europe, mostly focusing on packaging industry, then followed by construction and automotive industry. When we look at the management of this plastic production, consumption, the highest amount of production comes from China. China is the leader in the plastic production, plastic product production with 32%. Then it's followed by other Asian countries with 18%, followed by Europe and North America with 17 and 16% of production. So the highest amount, as I mentioned, goes for packaging production. And this is very much important for the end-of-pipe or end-of-life management strategies, where circular economy or Green Deal, these topics, or zero waste applications have been very much popular nowadays. And I'm sure you'll all know that plastics are the topics that the highest number of national, international research projects are being carried out. So during the last years, the amount of the percent of recycling has really increased. Of course, the Green Deal Action Plan, published in December 2019, declares that at least 8% of the plastics have to be recycled when used in industrial products. So this percent has already been achieved, and in addition, in Germany, in UK, percentages up to 17–18% have been also reached up. On the other hand, other than recycling, incineration is quite popular with energy and heat recovery issues. Of course, the final disposal landfills are still existing. Landfill sites, dumping sites, up to 50% in Europe, with the dumping sites included, and till 2035, less than 10% has to be disposed in the landfills, and the amount of recycling of plastics have to be increased by 65%. So these are quite important targets that our country, throughout our national action plans, have to reach. If we bring an integrated approach to plastic production and consumption and, let's say, disposal, final disposal, we have to start, as I've shown at the beginning, from crude oil production, then the manufacturing of plastics, polymer production, then later on with additives and certain other chemicals, fillers, etc., that we have the plastics, and then the inside recycling for plastics, pre-consumer, and then we have the consumption and post-consumption consumer recycling facilities are also applied. And also we have to think about different types of recycling methodologies without source separation or after source separation that will obviously show variations for the efficiency of recycled material utilization, and also energy or value-added chemical recovery, and also landfill, which is the final, of course, result. But of course, we have to prioritize the prevention of plastic consumption. So as you can see here, the list of the plastics that we are having in the market are listed. I'll just pass it through. So these are the definitions that you can understand. And I will, as you're all from marine environment, marine ecology, chemistry, I would like to say a few words about marine plastic pollution, especially microplastics. So the plastics, as you all know, disposed into the marine environment consists of 95% of plastics. And the amount of plastic waste in the Mediterranean region is 4 times more than the amount in the Pacific region. So the main source of these plastic wastes are coming from terrestrial activities, also from fisheries. So these are quite important. And first of all, of course, we have to prevent the generation of plastic waste. Other than that, after being able to be successful in the prevention of plastic waste, we have to consider step by step the management strategies. The reusability of plastics can be considered. After that, mechanical recycling, that you will be producing again a new raw material from the plastic waste without changing its form. After that, dissolution, and chemical recycling that we will focus on today. So chemical recycling mainly deals with depolymerization, cracking, end of chain cracking system, that we are trying to achieve the monomers or the value-added chemicals from plastic waste. Pyrolysis is one of the main processes working for this, and also we can include gasification, where we are having instant heat and energy from waste plastics. So the main idea here in gasification actually is production of syngas and conversion of this syngas into valuable hydrogen gas or methane gas. So it depends on your target, the type of product you need. Also for the pyrolysis process, by changing the temperature, the heating rate, the reactor type, the catalyst, inert gas additions, you can easily change the product profile. So it's very important to define the product that you need. Do you need storable fuel? Do you need value-added chemical? Or do you need to produce energy in the same time? So that's how you define your operation parameters. If you want to go for activated carbon production, for example, you need to go for low pyrolysis temperature, and you will be having huge amounts of char that you will achieve activated carbon. Or if you want to go for gaseous products with the carbon from carbon 1 to carbon 6, polyethylene, polypropylene are in this chain, that you need to maximize the temperature and you will be maximizing your gaseous yields. Or you can produce value-added chemicals that is very precious, toluene, hexane, other chemicals, from the oil, from the tar of this pyrolysis process. So again, when you look at the plastic characterization, there are various types of tests you have to carry out for its characterization. And when you look at these parameters, of course, we have to check the ash content, the moisture content, fixed carbon. Also, there is another parameter for the incineration process, gasification processes, that is hydrogen versus carbon at the bottom. So once you increase the ratio of hydrogen in those equations, then you will be increasing the energy you're producing. So let's bring a more general managerial approach that I would like to focus on life cycle assessment that covers eco-design, eco-label, circular economy, industrial symbiosis, and of course Green Deal, sustainable industry. These all terminologies are integrated into this LCA, which is at the top of the umbrella. And LC is also supported by international standards organizations, starting with ISO 14040. The scientific aspect of LCA is supported by SETAC, Society for Environmental Toxicology, and UN Environment has developed life cycle assessment methodology. So this is the general outline that you carry out input and output analysis, starting from raw material extraction, in this case it's oil and gas, and then you go for chemical production and you consume that chemical and you have it as waste, and then you try to dispose it, you try to recycle, recover it. So the whole chain with the whole inputs and outputs are analyzed through softwares, and then you carry out the impact category analysis. And then at the end, you go for endpoint impact analysis. So the midpoint impact category analysis are covering climate change, photochemical ozone formation, land use, acidification, eutrophication, different types of toxicology, where at the end, we try to sum them up for human health, ecological health, and resource conservation. So it's planet, people, profit concept. So we have to carry out all these inputs and outputs for each product, that at the end we can compare these two different products, two different plastics, or plastics with paper products or glass products, that we need to carry out the impact categories like, as I mentioned, for the mid categories, acidification, global warming, eutrophication, photochemical ozone formation, by summing up the related emissions listed here again. And then the units are defined again by SETAC, that for acidification, for example, we are using sulfur oxide, global warming, it is carbon dioxide, and eutrophication is defined by phosphate, photochemical ozone creation potential by ethane, etc. So when we look at, for example, when we look at the comparison of paper bag, plastic bag, two different products, but giving the same service, that's the important. You can use the two different bags in the supermarket for the same purpose. This is very important. So once we analyze the paper bag with its paper production, with the growth of tree, paper production, recycling of paper, utilization of paper bag, lifetime of paper bag, and disposal of this paper bag, and then we compare it with the plastic bag. How are we producing this plastic bag, and how are we consuming this plastic? What's the service of this plastic bag, and the disposals of this plastic? So each stage are analyzed from input and output analysis, and you can see that the low-density polyethylene has some advantages when compared with the paper bag. So photochemical ozone formation or other types of categories can be favored for this plastic bag. So you can never say plastic bag is worse than paper bag. The issue is that you have to carry out this tailor-made study. Another example that I would like to highlight is the comparison of two different bottles. This was a master's study carried out by my student Pelin. And we here got the data from Chevco. So plastic PET bottles compared with glass bottles are being carried out. The weights are completely different. The number of the bottles in one pallet are completely different. But they are carrying the same amount of good in themselves. It's for water. So again, you can see bu şeyler çok küçük. I hardly see them. So I cannot talk properly about them. Okay, so when we look at those results, we can see that again, for different recycling, landfill application scenarios, the different types of products show variations. Another study, again for shopping bags, and again, this was carried out for paper and plastic bags. Of course, when you're carrying out paper bag recycling, you have to focus on the paper sustainability index standards for forests. That's also very important. And this was another study that we have carried out at our university. It was quite an old study, but it was one of our basic studies for plastic weights, that we compared the plastic dishes for different disposal scenarios. So recycling, mechanical recycling, pyrolysis, incineration were all compared with each other. And we have seen that mechanical recycling and incineration are much more beneficial in comparison with pyrolysis, especially for polystyrene. So polystyrene is efficient for pyrolysis application. The reason for that is polystyrene favors monomer styrene formation and other value-added chemical formation when you pyrolyze it. Especially in the liquid part, you can have value-added chemicals, but these chemicals are in large groups. Aliphatic, aromatic, polar compounds are gathered together. So pyrolysis is quite expensive, and it needs after research, after the pyrolysis process. You need to segregate the aliphatic, aromatic, and polar compounds after the pyrolysis process. Okay. So this was a study from Denmark for Copenhagen plastic weights. There are about 13,000 tons of plastic weights on the annual basis, and different scenarios were carried out by Technical University of Denmark. So these are the basic scenarios. So life cycle assessment helps us again to compare the results of these different scenarios and to see which one is much more beneficial for the coming years, for 2035, depending on the targets of Green Deal, or for 2050. So the main scenarios start with incineration, and then we focus on mechanical recycling without separation, and in the third one we have pyrolysis for polyethylene, polypropylene, together with mechanical recycling for PET, then plastic waste mixed ones gasification, and then again PET for recycling, the rest for gasification, hydrogenation, and the last sixth one is recycling with source separation. So when we go for incineration process with the life cycle assessment approach, we have to bring the system boundaries where we have the inputs of different plastic weights, incineration, and the heat and electricity generation. So with all these inputs and outputs, with gaseous products, waste and emission products. And of course, when we go for the mechanical recycling, again, we have to consider the inventory analysis for each unit operation. That we will be focusing on global warming, acidification, eutrophication, photochemical ozone formation for the selected compounds, for the selected products. And here you can see that the sixth one, separation, recycling after source separation is the most promising one. The results show the same details, and we can conclude that once we have the plastic waste for utilization, we should go for mechanical recycling with source separation, followed by pyrolysis, especially for polystyrene, and hydrogenation. And the last one is gasification. But of course, in order to favor gasification, we have to maximize the hydrogen production in the gasification in the syngas. So that's all from my side. Thank you very much.
Thank you, Nilgün Hocam. I was trying to provide the presentation to you, but unfortunately I couldn't make it, and you are done with the presentation. And thank you very much for all the information that you have provided. As the unmanaged or difficulties due to the management of waste, we are facing this marine litter issue, and unfortunately it is a necessity for us to somehow cope with these waste management issues, and looks like with all the expectation from policy side, it's going to happen, and we need to be prepared for that one.
We are having 3 kilograms of fish versus 1 kilogram of plastic waste.
Yeah, I mean,
that's horrible, isn't it?
These are the things that the scientific community kind of stressing on it, and as said, the source is us, and the waste is there, and somehow we need to cope with it. And as you said, we need to benefit it with thinking.
Thank you so much.
Yeah, thanks. Then our next talk is from Dr. George Trefalero. He's the research director of the Institute of Oceanography at HCMR, and he's currently the coordinator of H2020 claim project. Also, he is in charge of several EU and national funded projects. He's also a scientific advisor of the HCMR spin-off company Minds, Technology and Environmental Sciences. I am giving the floor for him for his talk on collecting and recycling of micro and macro plastics using innovative technologies. Thank you.
Thank you very much. Good evening to everyone. I'm George Trefalero from HCMR, and I'm planning to give you a retrospective trip on the marine litter. So, I would like to start with this. 16 tons of plastic litter enter into the sea in 1 minute. That means that finishing my presentation, 240 and more tons of plastics will be into the sea. What is the meaning of that? This makes us to be afraid, because as the speculations come, the assumptions come, that in 2050 we will have more plastic than fish. And this is not good. So what's happening there and how they come? 90% comes from river, so the big problem is the river. 80% comes from mismanaged waste and untreated waste in the Mediterranean. 70% go to the bottom, and 15 are floating, and the last 15 goes to the beaches, which is not a pleasant figure. Plastic, cheap, useful, but harmful. As you may see, killing millions of wild animals every year. So we have also health effects. Recently, they found that we have microfibers in the human beings, in placentas. So imagine the problem that we may have from that. Additionally, I like to say that recycling plastic is more expensive than new ones. So the idea is to prevention than curation. That was the idea of the CLAIM project, where I started working on that and proposing. The idea is that to do in situ management before they go to the sea. If they go to the sea, it's very difficult to take them out. So to find solution to prevent this one. And we have 5 innovative devices. One device comes, the Clean Trash. As you may see, the Clean Trash is TRL9, and also is cost efficient. The performance is performing very nicely, about 80% to 90% can collect. It's highly automated, has platforms, 3 platforms. So away with Wi-Fi, you can remove one, get the other one to get the garbage. And also low maintenance, cost eco-friendly, and of course is sustainable, can last for a long time. This is to put in the mouth of the rivers. The next one is what we can do about microplastics. Microplastics, very important and very difficult, actually needs to have a pre-filtering system, since we use nanotechnology. That means photocatalytic reactor that works with the photocatalysis. The pre-filtering is TRL9, although the photocatalytic reactor is TRL6. The idea is that both of them, they can work together. The first one grabs the bigger parts of the plastics, so the photocatalysis using the smaller one is to be more efficient. Next, plastics is a new story. Before that, we have pollution, eutrophication, things like that. Now, except that, we have the plastic. So the idea is to develop something that can be used in the ferry boxes to find hotspots or where the plastics accumulate. And this has been developed. It's a filter with different seats and gets the different size of plastics and can be installed in ferry boxes. Already has been installed in 3 of them, Piraeus Heraklion, Tinis Marseille, Tinis Genova, Tallinn Helsinki. This is TRL9, so it can be used easily. The last one, we go to recycling. Recycling is a big thing, and I come back again. Iris from Italy has developed, I can say, updated, upgraded, 2 pyrolyzers. One is to be installed for ports, and the other one is to be installed in vessels. So this produces a combustible gas that they call it sea gas, and you can use this to charge batteries, to using for heating in ports, light, and so on. So I have to say that although is in this recycling, this does not produce any dioxin and furans. The big thing was the mathematical models. Mathematical models helped us to find out if a device is working efficiently. And that's the good thing. Another thing that I would like to say, it's a new mathematical models, because new things came into the model. Like what? The first one is biofouling. You know, plastics, they have biofouling, they change the density, and some of them will go to the bottom. Otherwise is the gradation, the composition of the plastics. As long as they stay in rocks and so on, they become small parts. So we have to take into account these two. And these are the new models that have been designed, not only using as passive tracer the plastic things, but actually take into account this story that is a close collaboration of the ecological model with the model that gives you the trajectories of the plastics. Of course, two different models, many different models, because plastics is not one. We have microplastics, macroplastics that might be bottles, foam, and so on. So we have different models to do with them. These methods, developed in CLEM, also is implemented in bridge for the Black Sea. Now, some results. To simulate the plastics, you need information from the coast, from the land. The most important comes on the left panel. I don't know if this one works. Go ahead. You see something? No, doesn't matter. On the left part, you have information that comes from the rivers, from the waste treatment plants, and also from coastal areas according to the population. But before I say something, I would like to validate the model. So we have make samples, particularly for the forecast of the model that has been in the Saronic Coast Gulf. And to the right, you see the real data, the blue one, with the model data, fine resolution and coarse resolution, that is the green and the yellow. Additionally, for the Mediterranean, cluster analysis shows areas that are affected with high concentrations. High concentrations, the red, green concentrations, the low, and the blue one is the middle. Now, Black Sea, preliminary results. And as you can see, we have the information for the rivers and also from the populations. In the middle, you see the microplastics concentration, annual means. And on the bottom, you may see the anchovy annual mean that comes. So you may have a comparison. Where is the anchovy and where is the plastic? What are the plastics? On the other side, to the right, a zoom in particular area, we have marine protected areas and areas that you have dolphins, and also in relation with the microplastics. That's some preliminary results. Yes, we care about the footprint. And the footprint means that CLEM technology should be also compared with different things. What is that? Cetaceans, Natura 2000, aquaculture, recreation beaches. Siggy Gruber also mentioned about the climate change. This is something that has to be done later. And also, microplastics reduction is about 87% of the devices that have been implemented. And for the macroplastics, there is a range from 13 to 14%, according to the sources, of course. Now, not only CLEM, that was CLEM, but actually there are other things. So the things goes on. We have progress. Of course, we have problems that have to be solved. And now we have the ocean cleanup. And also that was installed in Great Pacific Garbage Patch, collecting data. And they have other two things, the Sarga boat and the Sarga trailer. So it's a catamaran, the Sarga blow, with a conventional bed, collects garbage. I mean, surfing plastics, of course. And actually, there is the Sarga boat connected to the Sarga trailer, gets that and brings to the shore. Next one, Pangea. Barriers for the rivers, important. And also this, I have to say, has pipe with PVC and metal grates. And also we have the ocean cleanup interceptor, works with solar power. And also there is the boom, which is this floating barrier that has been to be attached in the river mouth. Additionally, we have the DIME litter trap system with funnel from Bolina barrier. This also is using artificial intelligence. That means recognize information that comes from some cameras that is in the bridge in order to be appropriately installed to get all the detritus or the plastics, if you like. Now, the mold. The mold, as you can see, is these plastic devices. There are axles connected to the bottom. This turns with the natural flow of the river and brings, I can say, not collects, the floating things to an area that you can see on the top. The bubble barrier. EU mission, also Siggy Gruber mentioned that. And what is the most important, it is that innovation from SMEs. Not only SMEs, but actually governments, municipality, scientists, and other people, citizens, work all together to have a solution regarding the plastics that comes into the river. Of course, I have to say that there are bubbles that comes up and produce a vertical flow, trapping the plastics. And one thing, the negative part is consuming energy. Pumping air means energy, and this is the only thing, except if it is close to a place that you can have easily electricity and you don't care about that. Now, we don't have only rivers, but we have marinas, ports, and so on. The sea bean. The sea bean is a very simple thing. The idea comes from swimming pools. It's a skimmer, sucking water, and as the water comes in, takes also the plastics. And the other part is the Waysark Aqua drone, which is a catamaran. The propeller is working with electricity. There are also sensors to get the the water quality. And also it's Wi-Fi like drones to drive it. Now I'd like to go to this. I get an example. A plastic bottle. 2/3 of the plastic bottles do not go for recycling. They go to landfill, and then we go for decomposition. Decomposition means 450 years, as you can read there, to decompose that. 1/3 only goes for recycling, and then there is a collection. You can see also prices over there. And after that, there is a separation. They separate from other things, not useful. Then the bottles are squashed and makes this kind of cubes. And then we go for reprocessing. They sell this one. For the reprocessing, the bottles are stored with different types of plastics. And then are chopped into flakes, pellets, if you like, washed. And of course, they have to be contaminated. Because, as I said in the beginning, things comes to the plastics where in the sea. Finally, that's the product. And this product to become, you can see there what kind of products you may have, like glasses, building blocks, shoes, and so on. Makes the thing to become more expensive than a new one, and we have to find solutions on that. Before I say thank you, I would like to set some questions. I think that there is an open issue for the microplastics. Microplastics, we don't have solutions till now. Needs work to be done for the microplastics. It comes from different places, particularly for the air. Also, you have the tire wear that produces these microplastics, and you breathe that, it goes to your lungs and your body. And actually, that's a problem maybe, when I said in the beginning that we have problems with human beings. That's a crucial question. The other thing is, what I mentioned before, we must find solutions even better for the recycling. Recycling is expensive. We need better solutions. That's all I had to say. Thank you for your time and consideration.
Thank you very much, George, for the presentation and all this information as it is important that we need to deal with the waste, it's also important to collect the available pollution and try to add it to the economic values. Thanks again. Our next talk will be on sustainable production and consumption practices and initiatives. Mr. Feng Wang from United Nations Program will make this talk for us, and Mr. Wang serves as a program officer in United Nations Environmental Program in Economy Division Paris office. He coordinates circularity work in United Nations Environmental Program on sectors of electronics and plastics, and manages projects in area of sustainable consumption and production, circular economy and extended producer responsibility and waste management. Also, Mr. Feng holds a doctorate on topics of eco-design and waste management.
Thank you very much for the introduction. I'm very happy to join the event online, and apologize for not being able to travel on site. Today I will give a very short presentation on the latest summary of plastic science and the solution. Actually, this document is a summary document that UNEP prepared for the upcoming Intergovernmental Negotiating Committee meeting. The first meeting will be held in 2 weeks' time in Uruguay, and this is a background document summarizing the main findings from existing science. So I will give a very brief introduction on the trend in plastic pollution, waste generation, and the chemical use in plastic production and consumption. And then we'll talk briefly into plastic pollution sources and pathway in the environment. And finally, I will mainly, that's the topic today, to talk about circular solutions in solving the plastic pollution issue. I think there has been already introduced and also emphasized by the previous two speakers, the professors, so I will not go into all the details of the data, but essentially what we have seen is that between 2000 and 2019, that in 20 years' time, the production of plastic has doubled in the 20 years. And if we look at the forecast between now and 2060, the production amount will be tripled from the level we are having now, around, let's say, 430 million tons per year, up to close to 1,300 tons in 2060. So there's overall recognition that the production of plastic will go, let's say, up very quickly due to the needs of different type of sectors and also consumption. When we look at the production by region, we see that in basically Asia Pacific dominates the production as the main region for producing the plastics, then followed by North America, Europe, and other regions. When we look at also per region, that non-OECD countries are expected to account for 64% of global use. However, when we look at not only the total amount but per capita, OECD country members are still, let's say, will be leading the consumption per capita. That's in 2060 around 238 kilogram compared to 77 kilogram in non-OECD country. So there is issue of intensity of consumption and also the overall population that contribute both to the high consumption level and indirectly to the production of plastics. So plastics is not only a waste issue but also a chemical issue. We can see that around a quarter of over 10,000 unique chemicals are used in production and also of plastics. And different type of chemicals, additives, and also other kind of chemicals are either unintentionally added as byproducts into the plastic, but also added as additive in plastic products. And averagely, we can find more than 20 additives per product in the plastic products, which will cause direct and indirect impacts to both human health and the environment. To support also the Intergovernmental Negotiating Committee meetings, there is also an info document specifically talk about the chemicals in plastics. when we look at both the production and also the consumption, there is always an end-of-life phase, and that's also being addressed a lot by different studies. We can see that a majority of the plastic consumption come from the packaging sector. That's more than 40% and almost close to 50%. However, we should not ignore that there are also plastic being used a lot in textile sector, construction and mobility, transportation, building construction, electrical and electric industry, and in many other sectors. And some of them are in the form of single-use packaging plastic products, but also some of them are in the form of the, let's say, durable goods. And they have different characteristics and contents along the plastic value chain. And this is where we're seeing that we have a very diverse application of plastic in different sectors. However, when we look at the recycling side or the end of life, around 40% goes to landfill. That's the other plastic had not properly utilized, but still ended up in the land environment. And there are also plastic going to the aquatic, river, marine environment, and around 40% are incinerated, and only around 10 to 11% are being actually recycled. So this is where we see that by looking at the plastic economy, a majority of the plastic still ended up in the environment, and this is really a big issue, posing to both resources, climate, and human health, and also the environment issues. This is the slide just to summarize all the data, and I think we use a lot of the data set from OECD and other researchers, and this is a kind of very brief summarized figure. You can look into that. When we look at this figure, you can see that the current plastic economy is largely linear from the left to the right, which means that more than 400 million tons of plastic are going into the environment, and they are being used and produced in different sectors. As we see that around 11% going to the marine environment, also quite a big portion of that going to landfill directly. As we see already 14% going to incineration. There's only a very, very small cycle. You can see it's the orange color going back to the production phase as recycled material or secondary resources. So this means that the current plastic economy is linear. It's creating a lot of leakage to the environment and generating a lot of impact. There's a very fundamental change to change the way of the product being produced, being designed, being sold, and also being consumed. So I'm not going to the details of the data, and happy to also share the document afterwards, which is summarized the key findings. Again, I think the previous professor also addressed plastic issues, not only the macroplastic we see, and also the microplastics that either coming directly from intentionally added microplastic in different products, but also coming from the secondary plastic that's degraded in the environment from the macroplastic. So we should see that the nature and also result of both macroplastic and microplastic are important, but they do have different mechanisms and also different reasons of forming that. And I think from the research and also the attention, a lot of work are currently being carried out on packaging. However, we should not, let's say, forget that in terms of impact, fishing gears and also fishing nets have very, very, let's say, strong and also critical impact into the aquatic environment and also to the species in the environment. Same for agricultural plastic that are usually overlooked, but use a lot of quantity of plastic for covering the field, and also even used microplastic in the seeds and fertilizers. So it's also a very critical area to be not to be overlooked. And we need to look into both the leakage of macroplastic, primary plastic, microplastic, and secondary plastic. Now let's look into the solution. When we thinking and also planning for a circular economy and also a circularity solution, by reflecting on the graph, if we talk about circular economy, I think there are two major elements to be considering. Is that as we see that the intensity and also the quantity of plastic being consumed and produced is really doubled and tripled in the coming years, is first of all to look into how much we can actually make the reduction. so that we use less, let's say, primary resources to produce plastics, but also reduce the overall use of plastic into the economy. And of course, the second issue is also looking to how much we can cycle it back and create more bigger size of loop instead of only the 11 and 10% we saw on the screen just now in the graph. So in order to define a pathway for circular economy, in our paper to support the negotiation, there are 4 pathways, or we call strategy goals. We identify focusing on 4 different aspects, focusing on elimination, focusing on innovation at product level, and also circulation for better reuse and recycle. And also the final one is also to deal with the waste that cannot be recycled and also the legacy waste. I will go into one by one to give some examples. The very first strategy goal we want to, if we want to achieve circular economy, is actually reduce the size of the problem by eliminating and substituting problematic unnecessary plastic, including hazardous additives. So this means that many of our products in the market actually can only be used for single time, and also the material quality and also the content is very low, which make it very difficult to recycle, reuse, and also easily to be either littered and disposed of as littering. At the same time, there are substantial amounts of chemicals being used in those products that need to be eliminated. So this is really that we have to think of very upstream waste minimization reduction from policy and from business models and also from design. So measures such as banning single-use plastics, banning plastic with hazardous additives, and also different, let's say, physical measures are very useful, so that we reduce the unnecessary plastic from the very source, so the unsustainable plastic going to the environment or going to the economy will be reduced from the source. While we also need to work on, let's say, sustainable product or circular product design that make sure the product are more reusable, recyclable, and compostable. Because nowadays, a majority of the packaging and also plastic product are designed to be used only single time or a very couple of time. This means that design phase are very critical to ensure that product can be actually reused and recycled, and through different standards, different regulation, and also different business model, so that product are designed to be more circular by its definition. And also to be more compostable, because that if we are able to make sure that product that can be compostable in certain conditions and actually being composted, this also reduces a lot of the leakage of plastic into the environment. The third element is actually also quite important, as we know that no matter how much we design the product in a more sustainable way, but at the end of the life of the plastics, if they are not actually being managed in the appropriate way, that even we can design a product in the perfect situation, there will be still loss of resources and leakage. This means that we have to make sure that when products reaching to the end of life, it's actually being really reduced and collected and recycled in the proper way. So this is where we need to work a lot with proper waste segregation, collection system, recycling, including both mechanical recycling and potentially chemical recycling, so that different type of product can be segregated for reuse and also for recycling. In this end, we also need to work a lot with the informal sector to make sure that they are not excluded in the solution, but also be complementary to the solution that usually government, municipality are introducing into the cycle. And especially for this action on closing the loop, investment and financing will be playing a very important role, because in order to make sure that plastic actually returned and also being reused and recycled into the system, there need to be investment not only into infrastructure, but also into the collection and take back, into also the overall setup of the waste management system, which has a bigger much demand into the countries. So this is really the third area. The last area is also that no matter how much we can redesign and rethink our system and also actually working on better waste management, there always a proportion of plastic can never be, let's say, reused or recycled. And also, we have facing another issue is that there are already plastic in the environment that ended up in landfill or in the ocean. What do we do with them? So there has to be different measures, first of all, to prevent the plastic cannot be recycled and reused going to the environment, and also to work on either trade and also transboundary movement to prevent that non-recyclable plastic entering the countries that without any infrastructure. And finally, we need to deal with the plastic that's still in the environment and how to make sure that they are not staying in the environment, but take them back and also to treat them. So this is the fourth and also the final solution. While we're looking to the system as a kind of economy, we usually look into the country level. However, there is a very, very important element looking to trade. This is really an element and also angle that's working across country, because plastic trade comprised of 5% of global economy, and trade of plastic happens not only at waste level, but also product level, polymer level, pallet level, and at end-of-life level. So this is where the trade of plastic and also plastic waste are generating both benefit for the countries, but also potentially, let's say, impact on climate, impact on potential, let's say, risk on waste management if the import country has no system to deal with that, and also other type of impact on chemicals and also on, let's say, pollution. And how to work not only in one country, but also between import and export countries, very, very important and useful to make sure that changes and also circular economy is happening across different countries at regional global level. While we are looking to not only the environmental impact that if we can aim for 80% of plastic pollution reduction by 2040, actually there's a chance that the impact for both pollution, chemicals, and greenhouse gas emissions will be reduced. And it can also potentially lead to net savings and also creating new jobs because we'll be working a lot on upstream intervention, new business model, and also social integration and also inclusiveness with the informal sector. So this is the benefit that we can integrate into the solution. This is a final slide to summarize the key learning. I think just to going back, there is a massive global increase in the plastic pollution that also ended up in plastic consumption and large amount of plastic waste. All the issues are creating impact to human health and to the environment and ecosystems. Some of the impact are related to chemicals and health and toxicity. Some of the impact are related to ecosystem and also other type of impact. So far, our economy is largely linear when you look at how plastic is being produced and also being, let's say, consumed and also disposed of. The critical element is to implement circular economy. However, as we can see that there's no one single solution can resolve the issue of circular economy. We need to look into different type of strategy from very, very upstream to midstream and to downstream. Also a combination of different strategy to reduce and also to eliminate and also to circulate by using different policy instruments as well as economic instruments and also investment plans. And there's no one single solution, and there's no one single, let's say, effective solution, no silver bullets, unfortunately. This means that different solutions need to come together. So we do not only need technology, but also knowledge, capacity, policy, investment, finance mechanism, and also awareness raising. In order to do so, that everything needs to be designed in a way that can work according to each other and also in harmonization. Finally, we need to have a system change. This means altogether we need to form a very collective vision what to do and also build a system to monitor the progress and also to report progress. And this is where the end of my presentation. It gives an overall view of the issues, but also the way forward. Thank you so much.
Thank you very much, Mr. Wang, and thanks for the presentation that give a broad perspective of plastic life cycles and the difficulties that we are in need of facing through that life cycle and the importance of plastic circularity. And the final talk in our plastic circularity session is on plastic circularity, and Mr. Shardul Agrawal will give this talk. Mr. Agrawala is the head of Environmental and Economical Integration Division at the OECD Environmental Directorate. In his capacity, Dr. Agrawala leads the Directorate's work on economical environmental modeling, empirical analysis of environmental policies, trade and environment, and on resource productivity and waste. I would like to give the floor to Mr. Agrawala. Mr. Agrawala, we can't hear your voice.
Sorry, can you hear me better?
Yes, now we can hear. Thanks.
Okay. Sorry about that.
No.
Good evening to all of you, and I'm going to share my screen now. I hope you can see my screen now.
Yes, we can see the screen. Yeah.
Okay, so I'm going to be presenting some key findings from OECD's Global Plastics Outlook, and some of those findings have already been mentioned by the previous speaker from UNEP. But just to give you another broad perspective on the plastics problem, concern over plastics pollution really took off in the last 6 years or so, and a lot of it has been driven by scientific research on marine plastic pollution. There was a landmark paper in 2015 which quantified the scale of the problem. There were several other papers after that. There was a very famous film, again showing the problem of plastic pollution. And then there was a lot of policy action from banning certain single-use plastics to import bans of plastic waste, starting with China, and then other countries, ultimately leading to changes in the Basel Convention. And more recently, there were concerns about plastic waste in the context of the COVID-19 pandemic. And of course, this year we had the landmark resolution at UNEA 5.2, which is starting the process towards a plastics treaty. So that's the policy or public concern about plastics pollution in very quick terms. Now, within that broad context, I wanted to situate the work we have done over the last 4 years. And we produced 2 volumes of the Global Plastics Outlook, which were both released this year. So this is the first comprehensive mapping of the life cycle of plastics globally. We also don't just look at plastics in the aggregate, we're looking at 14 polymers, we're looking at micro and macroplastics, and we're tracing the plastics value chain through the life cycle. We're also looking at what happens at the end of the pipe. We're looking not only at leakage to water and marine systems, but also leakage on land and in the atmosphere. And then what we tried to do was look at where different countries around the world are in terms of policies to address plastics leakage, and what would happen if we don't undertake more ambitious policies. How would the problem change in 2060? And what kind of policies can be designed to eliminate leakage over the same time horizon. So that's the contribution of these 2 volumes of the Plastics Outlook. So just coming to some of the key findings, this is just the situation up to 2021. The consumption of plastics has grown dramatically from nearly 0 in 1950 to 460 million tons in 2019. Now, you can see that the consumption declined first during the global financial crisis and again during the COVID-19 pandemic, but these declines were very short-lived and consumption and production both picked up very quickly after that. Now, in 2019, we were consuming 460 million tons of plastic. which is the weight of 45,500 Eiffel Towers, just to put it in perspective. The growth over the past 2 decades in plastics production and consumption is 40% faster than global GDP over the same period. Plastics are also linked to the climate change problem, and plastics life cycle contributes 1.8 gigatons of greenhouse gas emissions annually. And in terms of consumption, there are wide disparities across countries. The average consumption is 156 kilograms per capita per year in OECD countries and 39 kilograms per capita per year in the non-OECD. But of course, there are big variations both within the OECD countries and within non-OECD countries. Now, plastics use, if we don't undertake stronger policies, is projected to triple by 2060. So this is the picture we had in 2019 and 2020, and these are our projections for 2060, 1.23 billion tons of plastics use by 2060. And these are the growth rates between now and 2060 in different parts of the world. So what you can see is for most of the OECD countries, we are projecting a doubling of plastic use from present levels. But in some of the emerging economies, for example, for India, we are projecting an increase by 5.5 times, and in sub-Saharan Africa, an increase by 6.5 times. So there's clearly big heterogeneity in terms of how fast plastics use would grow in different parts of the world. The other part of the story is, of course, how much waste we generate from our consumption of plastics. In 2019, it was 353 million tons. And again, up to 2060, we are expecting a tripling of plastics waste. How is this waste partitioned? 40% of this waste is from packaging with lifetimes of less than 6 months. Another 12% is from consumer products with lifetimes of 3 years or less. Then we have textiles with lifetimes up to 5 years on average. And then you have more durable products like plastics and consumer goods and so on, which constitute roughly 37%. So more than half of the plastic waste that's generated is coming from applications with lifetimes of less than 5 years. And if you look at the life cycle of plastics right now, it's only 8% circular, meaning only 8% of the waste we generated is actually making its way back through recycled plastics into productive activities. So now just looking at this entire life cycle, and this is the mapping we have done as part of the Global Plastics Outlook. The previous speaker also shared this slide. So you have 460 million tons going into the economy. Most of it is coming from fossil fuel plastics, and there's very little secondary plastics currently going into the economy. We're producing 353 million tons of waste, half of which is landfilled. 67 million tons is incinerated. A very small share is actually being collected for recycling. And a lot of it, 82 million tons, is being mismanaged and littered. And when you're talking about the marine litter problem, it's this part which is most relevant. So if you break the mismanaged into different categories, we have microplastics leakage, we have aquatic leakage both to rivers and to oceans, but we also have leakage on land, we have leakage to the atmosphere through open pit burning, and then we have a lot of illegal dump sites where a lot of plastic waste is just littered on land. So 22 million tons per year is leaking into the environment. And just to dig a bit deeper to the aquatic problem, 6 million tons per year is going to the aquatic environment. And it's both rivers and oceans. Rivers are both a vehicle for transporting plastic waste to the ocean, but they're also a huge sink in and of themselves. And we estimate that the accumulated stock of plastics in rivers and lakes is 109 million tons. And then a certain fraction of it is going to the ocean, and that's the quantification we have of the flows to the ocean. So it's both a marine litter problem, but it's also a huge problem when you're talking about leakage of plastics to our rivers. And we need to look at both aspects when we're designing technological and policy solutions. We also looked at how policies around the world are addressing or not the problem of plastics leakage. So we looked at 50 countries, and you can see the map of the world. of those 50 countries, only 13 countries incentivize sorting of waste at source. About half of them have instruments to incentivize recycling. A lot more have regulations for schemes like extended producer responsibility, where the producer of a product takes responsibility for the end-of-life management. A lot more countries, both among these 50 but also around the world, have recently put in place bans and taxes on single-use plastic items. The problem is that these waste streams are very small relative to the overall scale of the problem. And the biggest issue for us is that most countries do not have adequate incentives in place to reduce plastics demand in the first place, and also to improve product design for circularity. So what do we recommend needs to be done? And we came up with a very simple roadmap for ending plastics leakage. For countries which don't have sanitary waste management systems in place, the key priority is to close the leakage pathways, which requires huge investments in collection and disposal infrastructure, but also banning or taxing frequently littered items. But then we need to move further upstream. We need to create better incentives for plastics recycling and sorting its source, and there are a number of policy instruments that can be used for that. But most importantly, we need to move even further upstream. We need to significantly restrain demand for unnecessary uses of plastics or where other substitutes which are environmentally beneficial are available. And we also need to set up incentives to design for plastics circularity, so close the different loops of the plastics so that they stay in the economy as long as possible and do not end up as waste, especially mismanaged waste. So what happens into the future if we put these kinds of policies in place? And I'm just going to show you the impact of these kinds of policy measures. So in 2060, we are projecting 1.23 billion tons of plastics in the economy, and the share of secondary plastics is 144 million tons. Now, if we put the policies which I outlined in a coordinated way globally, then we cut down plastics use quite significantly from 1.2 billion tons to 820 million tons. We'll increase the amount of recycled plastics more than double. We'll cut down on waste, so from over 1 billion tons to 680 million tons. But most importantly, we're going to virtually eliminate the mismanaged plastic waste, which is the source of leakage. And so it can drop from 153 million tons down to 6 million tons. And you can see the streams going to land, water, and so on. So it is feasible to reduce leakage or virtually eliminate it. But it requires policies to first reduce demand of plastics, to increase recycling, to extend the useful life of plastics, and finally to eliminate the mismanaged waste. How much will it cost? According to our modeling, there is going to be a cost globally. It's going to be roughly 0.7% of GDP. But you can see that there's a big heterogeneity in cost. And some parts of the world, for example, the region which is called Other Africa, which is sub-Saharan Africa, will have costs which could be as high as almost 3% of GDP. So any commitments through the international treaty process also need to look at financing for all countries to be able to take up ambitious action. So now I come to some final takeaways from our two Global Plastics Outlook. Plastic leakage to the environment can be drastically reduced at modest costs overall to the global economy, but eliminating leakage requires global action on all aspects of plastics life cycle, from restraining demand to enhancing circularity and to closing leakage pathways. Costs as a share of GDP will be higher for many developing countries, and so we need to look at financing mechanisms. And even if leakage is eliminated, and this is a key point, there are already significant stocks of accumulated plastics in both rivers and oceans, and those stocks are still projected to double, and a lot of those stocks will also lead to decomposition and ultimately generation of more microplastics. So we also need flanking efforts to tackle cleanup as well. It's not just about stopping additional leakage. We also may need to address cleanup both of rivers and oceans where it's feasible and does not cause other environmental damage. We also need more granularity in our policy discussions because we shouldn't just look at plastics in the aggregate. We need to look at different applications, different polymers, different stages of the life cycle, because how we respond depends upon all these specific aspects. And finally, we need to broaden the locus of plastic pollution. Marine litter is extremely important, but we also need to look at rivers. We also need to look at pollution on land. We need to look at impacts on air quality and also on greenhouse gas emissions. So with that, I thank you for your attention.
Thank you very much, Mr. Agrawala. I believe this plastic outlook provide us a broader perspective of what we are dealing with and what needs to be done as soon as possible. Thank with the four talks that we have listened, I believe we are now much more aware of the possibilities and the difficulties that we need to deal in terms of plastic pollution around the world. I would like to ask the audience if they have any questions to our speakers. Yes, please.
Yes, congratulations for these very extremely interesting presentations. I'm George Triadafilidis from Mainz. I would like to ask, because I share the same figures with Dr. Feng Wang, that the circular plastics are around 8%. So I have seen that Professor Nilgun Kuran presented somehow a more optimistic way that the circularity is a lot higher. So first of all, do you agree with this number, that it is only 8%, or how do you advise us that we can improve this?
Is it to me? Or?
Evet, size sordu hocam.
So you're asking the questions about the circularity of plastics. Okay, thank you. Thank you so much. When we consider the recycling or other thermochemical processes, first of all, of course, we have to minimize plastic production and plastic consumption. And after that, if we consider the recycling applications, we have to check the market. I mean, is that plastic is being used instead of a paper bag or a glass bottle? And then we have to bring this life cycle approach. So when we bring the life cycle assessment approach, a tailor-made study for decision making, the results will really show variations. For example, for global warming potential, a plastic bag can be much more environmentally friendly than a paper bag, that we can see the results from the study. And also we have carried out a study for plastic and for the comparison of plastic and glass bottles for Turkish data, for Turkish production data, and we have applied life cycle assessment software. And again, we have seen that in certain cases, plastics can be much more friendly because the melting point of glass bottles are much more higher, leading to higher amounts of CO2 emissions, and they are heavy for the trucks, that the transportation will bring higher emission rates, and the recycling points are important. The recycling places, are they close to transfer stations or source separation points? So recycling, if we consider source separation, of course it's very much beneficial. But if we don't have the source separation, I have also shown you some results that mechanical recycling doesn't have so much advantages when compared to other end-of-life scenarios. Incineration, when compared with gasification, can be a solution prior to landfill. In this case, we have to consider the optimization of syngas production, the composition of the syngas that we will be using for the further steps. So we have to carry out a detailed study to understand whether that process is suitable for that type of plastic or not in that specific area.
Yeah. I think Mr. Agrawal also something to add on this.
Yes, I can. I think I might be able to address what the confusion that the speaker was pointing to. I think in the slides that the professor showed, some of the data was from Plastics Europe, so that might be data from Europe. The numbers I was presenting, and I think which were there in the UN presentation, were also global. So the numbers for Europe might be higher. The other point is that there is no unique definition of plastic circularity. Sometimes it's used interchangeably with recycling rate, but of course not all material that's collected for recycling actually gets recycled. There are losses in the middle. And so what we were looking at was what is the share of the plastics that is ultimately recycled after the losses as a share of the total waste we generate. So that's how we got the 8% figure. But so it's two things, is it global data we're looking at, is it Europe data, or from a specific country, and how we define circularity.
Thank you. I believe this reply is enough. Yeah, thanks. We have another question here. Yes, please. Will you please?
Thank you. Lucia Bilecki from Institute of Zoology, Chisinau, Moldova. We have our team have a question for our expert from Greece. Our question is very practical. We saw on a slide about technology, how to collect macroplastics in open waters in the sea and use large nets. How to avoid to catch fish with when collecting bottles? How deep are these nets? And one more question. Why to remove sargassum, this big algae, only to avoid the eutrophication, or there is another reason? Thank you.
I hope the question was for me, eh?
Yes, both.
Yeah. Usually the clear stuff, the boom one, leaves a space from the bottom in order to fish to have the capability to move. So we don't catch fish in the net. There is an opening at the bottom for the fish in order to do the job. For the eutrophication, it's a difficult question I cannot answer. Sometimes, you collect material. Eutrophication is something that is not controlled by the device, but actually from the environment, what comes into the sea. And afterwards, it's the nitrates, phosphates, and so on that makes the eutrophication to be. The device that I proposed and I suggested is to be implemented in river mouths, actually, you see. There you are. I don't know if I answered your question.
Do we have one more question? Yeah, one more question there.
Hello, my name is Mine Tekman. I'm from Alfred Wegener Institute, working on plastic pollution in the Arctic, and I have a question for Mr. Wang. He showed that this 80% plastic reduction in...
I believe
is not here?
Yeah, not there.
No?
He's not online.
Okay, then I don't think anybody else can say anything because,
Okay.
yeah.
So maybe we can pass this question by
Yeah,
email.
that would be really awesome because, there's this plastic treaty coming in a few weeks, and he showed slides about 80% reduction in plastic production. So
Yes.
I'm just curious if United Nations is aiming for 80% reduction in plastic production in those negotiations.
Yep. Let's pass this the question to him and then.
Yeah.
Mr. Agrawal, do you prefer to answer that question?
I can answer that. I think what he meant was 80% reduction in plastic pollution, not plastic production. So it's leakage. I don't know.
Plastic production for some reason.
Okay, no, I don't know, but I know they're trying to stop pollution. It's not about stopping production. So, but again, I think maybe he should respond. But that's my guess that he was talking about pollution, not production.
Thank you. Yes.
Thank you, Olgaç. Great session, and especially with the UNEP and OECD talks, I have learned a lot. I didn't know, especially these new trends and projections. But especially after hearing those, I'm a little bit more pessimistic. Looks like the trends will continue even after implementing hard to implement policies, countries coming together. So in that regard, especially what Nilgün Hoca presented seemed to me a lot more important now, these new innovative ways. But what's the level of investment, Hocam, in these new chemical and environmental processes that you are developing? What's the interest from the industry, or do you get enough sufficient investment in these solutions to upscale them?
Chemical recycling, thermal degradation processes that we are focusing on, mainly pyrolysis, recovery of value-added petrochemicals. Of course, they are quite expensive processes, but they are being supported by various policies, protocols, action plans. So also petroleum companies, they are supporting such solutions. And when you consider the life cycle assessment approach, you can understand how much oil that you will be recovering. And of course, when you're producing those chemicals from oil and gas, you will be also having various types of pollutants when you're extracting. So you're also eliminating pollution arising from that resource extraction, resource depletion. So if you consider the life cycle environmental cost analysis, it will be beneficial. But of course, the certain amount of waste you're collecting is important. The size, the scale of the reactor, and the venue that you're installing the reactor. So maybe portable reactors can also be considered for this purpose, that we observe them, I think, in the United States to a number of applications. So there are certain issues to be taken into account.
We have a question from...
Okay. If there are no other questions, I can ask
Yeah,
one.
this is your
Okay.
question.
My question is for Mr. Agrawala. These climate projections towards 2060, I think they're all a bit surprising for all of us. I was wondering if these are business as usual scenarios, or they consider the expected policy changes of the countries.
Just so I understand it, are you talking about the plastics projections? Or
Plastic consumption.
Yeah. So the trends in plastics consumption, the tripling of plastics consumption between now and 2060, that's under business as usual. So
Okay.
it count current policies, but it doesn't take into account any additional.
Okay, so we shouldn't be that pessimistic, because we hope
Right.
that these policies will change, right?
Yes, but then
Okay.
if you had ambitious policies, you could actually reduce demand, for example, quite significantly, waste also.
Okay, thank you.
Do we have any other questions? Then I guess it's time for us for the closing session for today's meeting. Barış Hocam, will you please?
Okay, it was really a very exciting day and excellent interventions, I must say. We have started with the policy tools, and I think those were also very important for the Connect project partners as well. So we will definitely consider them during the next 6 months towards the development of the implementation plan. But also it was very important to see how the policies will develop within the next few years from DG Mare and DG RTD, and it was very important to understand the standpoint of view of BSEC and the Black Sea Commission. And yeah, and the mission, Ocean and Waters, I mean, it proposes many new opportunities. And then, as I have said at the beginning, I mean, this action forum is not about just understanding the status in our seas, but it's about discussing the opportunities and the solutions. And towards that, it was very important to understand the state of the seas, and several of the researchers has presented these. And then we have switched to the circularity. And tomorrow, we will continue with the best practices. There are many interesting and important projects as good examples. So please, we will expect all of you again, and all your input is very welcome. And at the end, we will have a panel, and the panelists will be from the operational network of funders of the Black Sea Connect. And now I would like to ask Pınar to tell you about a few of the logistics for tonight and tomorrow. And thank you again.
Thank you. Thank you, everyone. Just a few reminders of what has been already said today. So we have a foyer area for you, as you have already discovered. First of all, we have the photo contest of the Black Sea Young Ambassadors campaign. It's organized by one of our Romanian ambassadors. So you will also see some of the winners of this contest. So please have a look at them. Also, a second exhibition that you have already seen from Shinasi Yelkenci, who is collecting marine litter and turning them into art pieces, as you can see from outside. And yeah, his exhibition is called Confrontation, so which tells a lot. So we invite you to discover that. And he's here with us today if you have any questions for him. And of course, as you have already discovered, we have very important scientific outputs demonstrated in the poster boards. It's very important that we also focus on the scientific input. And lastly, we will have the reception in the right after the program closes in the foyer area as well, and you will get to discover all these. But before we go to that, I would like to invite Alexander Liuashvili. Apologies for my pronunciation. He is the founder of the Ginventure company, which produces USB cables made out of plastic waste. So we will just hear his pitch for a few minutes, and then you can discover their stand in the foyer area, where they can also show you some of the USB cables that they have for you, actually. Please.
Thank you very much. We are very happy to be here. Here are many NGO organizations, and we are business. I'm a businessman. I'm here as a businessman, and I just want to share my small experience with you that I have in my country. My journey generally starts when in 2000, when I was a student. I had my first car, and in that period, in Georgia, there was very few recycle bins, and me and my friends all day long we were riding to different places, and I was collecting all the garbage in plastic bags in the car. And I remember first time when I was 16 how much I was shocked when I realized how much waste we were generating during one day, and it was happening every day. The shock was bigger when I realized how much would generate 6 billion people, the population in the world for that time. Since that, 2 decades have passed, and this problem wasn't solved. Even the world became even a more polluted place, because we are already 11 billion. and 11 billion are polluting the world, and the world does not have any more time. Where we will cause new mass dying of all living species, so we need to do something urgently. We need to wake up to change the situation. And I believe that we can do it, and we're gonna do it. In my case, with my example, I want to explain that very important to help this problem is involvement of small businesses. First, when I went to China to understand how to produce USB cables, I was explained that I need to use different polymers, plastic polymers. I need to import them to Georgia, and this, I understood that this would cause in the future more pollution, and I didn't want to do it. And I didn't have any scientific background. I just started experimenting different polymers. I thought first that I would use the PET bottle, the plastic bottle, but it didn't work. I moved to different plastics. At the end, I found bottle caps that worked well, and I made the USB cable from bottle caps, and this was very big success. Then I told to people that we do things like this. Everybody were surprised. This is something new in Georgia. Yet, Georgian producers are not obliged to use recycled plastic in their productions. But I did it because I wanted to help the world. And the result was fantastic for me, for our company. Because we were using recycled plastic, my company became very, very popular in Georgia. My sales increased, and I would recommend to any business to get involved in recycling, to use the recycled materials, and it will bring to them the bigger fame and fortune and sales. So this is how we can save the world with one small example. Thank you very much. I forgot to say, we brought cables that are made in Georgia here, and we want to give as a present to all of participants of this event. Thank you.
Okay, now we invite you all to our networking reception. Food and drinks are available. Also, don't forget to visit the posters and the exhibition. Thanks a lot.